Hi, this is Tom Nelson. There's a lot of good stuff in this podcast with my guest, Brian Catt, who is a physicist and an engineer. He's done really good work to compare reality with the crazy climate models. He brings out his guitar. He brings out a letter written to him by James Lovelock. And I really enjoyed talking to Brian. Take it away, Brian.
Well, hi.
Hi, good to see you.
As easy as that.
Yes.
It's a pleasure. It's always nice. It's nice to be getting an audience at last. And so glad some of you won't know that I've introduced Tom to Doug Lightfoot, who's Tom recorded earlier this week. He was very close to the beginning of my journey through this, so I don't want to bore you, but I'll try and be really quick. I'm a professional physicist, electronic engineer, electrical engineer, and worked in instrumentation and advanced research until I was about 32, and then realized I needed to get more money to buy a decent house to bring the kids up in that I hadn't got yet. So I went to one of the two business schools in the UK and got an MBA, and then I worked in technology business. I went to the company that had just invented the CT scanner, then worked in ultrasound scanning, then computer printers and communications, instruments, all kinds of stuff. So it's applied technology has been my life, and it has to be applied technology that works, like it says on the label. So you can't make it up. You can't make something that's too expensive and sell it because nobody will buy it. They'll buy from the wretched competition, and you can't just go and ban the competition by writing a law. So all very relevant to what's happening now with energy. So that's my background. When I retired, my interest immediately turned to the subject of energy supply because I couldn't quite understand what was going on. I knew nuclear power because radiation physics was one of my subjects. I knew about waste, I knew about nuclear reactors, all that stuff, simple old nuclear physics. And I knew what had happened at Fukushima and Chernobyl, and why it wasn't actually a real problem, and how relatively safe radiation the nuclear reactors are compared to any other form of generation, all that stuff. So I knew that, and I thought, well, how are these windmills going to generate more energy, and these water mills, whatever, going to generate more energy now than they did in feudal times when they were our only power source, along with draft animals, horses, carts, and humans, of course. The more humans you had, the more work you could get done. So life was all about conquering more humans and more land, so you got richer. That's why Britain had an empire, this stupid little island, because we had an industrial revolution. We commanded so much energy per person that we could make all these goods and weapons and go out and shoot all the other guys. So people sort of put their hands up and gave us their raw materials, and we did quite well for a bit. So that's what energy does for you. And I knew this. I mean, I knew energy intensity was core to everything. So I went to look at how they'd improved and changed the technologies. And of course, they couldn't have, because the energy source is still as weak as it ever was. It's a very low grade energy, wind power. So is solar, relatively, solar power, unless you live in a useless hot place like Southern America or Texas or California, somewhere like that, where you live in the desert and use too much water and put your aircon on, which is a good use of solar power because you get your energy when you have the need for it in the middle of the day. In the UK, solar power is utterly useless. It's got about 11% duty factor. The sun's almost grazing the surface in the winter. If there's no wind, we've got no renewables, and which means you've got to be able to supply 100% of your energy from whatever dispatchable power you have, dispatchable being the 100% always available power. So eventually, when fossil's gone, that can only be nuclear, right? It's worth saying that again. When fossil has gone, the only thing that is intense enough to replace it is nuclear power. You can't do it with something which isn't there half or a third the time and is very weak anyway. It uses something like 10 times the natural resources to build an equivalent capacity plant. And basically, it's a waste of money. The only way you're going to sell that, remember my point earlier, is by subsidizing it and telling people they have to buy it. In a democracy, and one where you're supposed to be competitive with the rest of the world who is not following these rules, like Mr. Z across the sea, over the sea, that's a dumb thing to do. But we have very dumb politicians. They're so stupid they can't even do basic maths and understand the numbers, never mind the physics. So they'll just believe whatever makes them a lot of money, which they get from the subsidies by being directors of the companies that get the subsidies. So, and the people, of course, who make the wind farms and the water mills and whatever it is they make, guess what? They're engineers, but they're engineers there who are there to make money. So the government comes along and says, can you build us these windmills or these water mills? And they say, well, it's not a good idea to themselves. And they say to the government, well, yes, how much will you give us for them? You say, oh, we'll pay you twice as much as what they're worth in terms of what we can do with gas or coal. I say, fine. Is that guaranteed for 20 years? Yeah, anything you want. So they're laughing. They're making fortunes for doing something really stupid with energy, which is doing everybody in the West down. And the reasons for that we can possibly go into later. So anyway, after about 5 years of this, I'd beaten my head against the wall several times, going around loop after loop, trying to see what was wrong with the argument and that maybe there was something good about wind and solar. And the answer was there might be something good about solar in hot countries where the supply is matched to the actual demand. But the rest of it was just a complete crock, as we say in engineering and physics and business. All bullshit. There's a lot of people making a lot of money very quickly from it, at the expense of the people who are forced to pay for it by law. So it's what I call this is legalized crime, or it's a protection racket. Basically, it's a legalized protection racket where you're told the planet will catch fire unless you pay up. They just take the money off you by law in this case. So then I got to, why is this happening? Well, it's all this CO2 coming from the combustion that's causing all the problem. So, let's have a look at the science. Even worse. With engineering, you can see what is the case. I mean, you know the laws of physics, you know what the energy density of fuels is, you know, you can do as David Mackay did in his most excellent book, Sustainable Energy Without the Hot Air, which I recommend any of you to read. He went through it all and did it in terms of land use, in fact, and resources use. So I got in touch with David and several other people. And again, to ask where to look for the weather information, they pointed me in the various directions there were. I looked at all the arguments and all the standard Twitter sort of exchanges, which were very stale and very unscientific as far as I could see. I.e., they weren't proper debates about the data and what the observations showed. They were about whether the predictions and models were right, by arguing about which bit of the models was right and how big it was. Nobody ever really wanted to compare it to what the actual observations were. So it took a while for me to find those. And now we've got to, and guess what? It's all a crock again, as we can discuss. So I found all sorts of things when I went looking, but the thing that struck me most, and still strikes me the most, was the actual records or the observations which either prove or disprove the predictions of models. I then got into the models, and I know about models because when I was at Imperial College, the last thing I did before business school, I worked in complex, multivariate, nonlinear, unstochastic models, or in stochastic systems, which is what a chemical process plant is, and we were trying to control one with a computer. So one of the things I learned very fast with that is, if it's working on its own, don't try and make it better, because it will go into oscillation and disappear in a big heat, and valves would go off and nasty dangerous stuff would squirt out of relief valves all over the university lab. This was 3 stories of university labs and tons of equipment, so it was quite fun. Those were in the days when you could climb up without a safety harness to fix one of the analyzers on the column and stuff. They don't let you do that now. They probably have to bring in an army and gantry and stuff. Well, we did consider lowering each other down from the roofs on the those chain Wheatstone pulleys that we had to put a hook on the harness. But anyway, I knew about control systems is the point, and I couldn't see that what they were arguing had anything to do with my understanding of transfer functions and controls and feedbacks. The models looked like garbage, but it was a very, Tom, give me a word, and sort of nebulous, you couldn't prove or disprove anything from the argument.
Is that what, vague, or I don't know?
Well, whatever, yeah. Well, it's Feynman's definition of a problem. If you don't have a definite theory, you can't prove it right or wrong. And he does the example of how much love is enough for a kid. Right. And the punchline is, the kid obviously wasn't loved enough by his mother. And they said, well, no, actually, they check, and he was. Oh, well, must have been too much love then. He said, which shows, so if you have a vague theory, as he says, and he gets the laugh there. And he said, but you can prove, if you said up front, definitely how much love was enough, then you could check or prove or disprove the theory. And that was the only thing you varied, by the way.
Yes.
So ceteris paribus, that's cool. You only move one thing and you see what the effect is.
Yes.
And then, of course, the sociologists, which is not a science, as Feynman points out, sociologists say, oh, well, it's really hard in this sort of science to say how much is enough and how much isn't enough. And he says, well, then you can't claim to know anything. Right. So that's what a vague theory does for you, and that's what a vague model does for you. I'll show you what my favorite was. And this is called a trope by the, whatever a trope is, it keeps coming. When I was arguing with idiots on Facebook, who were generally people with literary degrees and were totally innumerate, they said this was a trope, this diagram, because it stopped at 1850. This is one of the stories you'll get. This is GISP 2. This is hand plotted by Brian, not robots, in Excel from the original data from Ali et al., Richard Ali, who I've communicated with even on this. He actually answers his mail, which is more than half of these so-called scientists do. And it's really simple to explain for me. So I'll try and mess it up.
Okay.
This is 8,000 years of a very short period, sorry, 10,000 years, in fact, of a very short period known as the interglacial. And our one, it happens every 100,000 years, and our one is known as the Holocene. Okay, so this bit across here, you'll see it represented in all sorts of different ways. But this bit here is from 8,000 to 3,000 years, and the temperatures were about there. These lines are 1 degree apart. You can see the thousands of years up the top there. And I can always, if anybody wants any part of this, or you can't have any part of me, but nobody wants it now anyway, past its sell-by date. But if you want any part of these diagrams, I'll happily send them to you. You just have to ask through Tom, I suppose. And
perfect. Yeah.
Right. So if you look here, 3,000 years ago is the Minoan period. Here is the Roman period. Here's the medieval period, and that's the little ice age there. And in fact, it is not true that the data ends from Ali's data from Greenland. This is from Greenland, so I didn't say that. Ends in 1850. It goes on to about 1905 here. And I think up there, I said 115 years ago, because I did this a little while ago. Okay. Now, all I did here was I literally took, still got the original data for this. I took this step from the actual points on the Excel data that I downloaded from Ali's site. And all I did was divide the degrees rise by the number of years they took. Nice and simple. So I got 0.8 there, 0.59 there, 0.65 there. So being a good empirical physicist, I said, well, I'll take it, split it down the middle, and I'll call it 0.7 degrees per annum, kind of an average rate of rise, because what I'm looking for is whether now is different from then. Is this exceptional? Is there an anomaly? Don't know. First of all, in order for the IPCC models to work, which is why this is so important, it's really important. This one thing alone I'm going to say is massively important. This period here, from 2,000 years ago to now, is assumed to be effectively no change until 1850. That's what the IPCC models understand to be the case when they're run. So there is no change, no natural change at all, 0.2 of a degree actually, but more or less, from 2,000 years ago. It used to be 1,000 years ago, and that was done by a charlatan called Mike. I've got his box here. Charlatan called Michael Mann, and he had a filter that he used to basically distort the data and concatenated different data series together, cherry-picked, complete nonsense. But it was used by the IPCC because it supported what they said was the case. And there's another guy who did it called Marcotte, and it's still on the NASA site. It's what's the word? It's a disgrace to science that NASA are actually doing that, because they know what the truth is. They're good at rockets, as somebody has pointed out to me, and I answered back, yeah, but rocket science isn't climate science. And they blow the rockets up too. They fried 3 crews, so they're not perfect. So what we have here is an absolute dichotomy between the observations of nature. This is actually from ice cores. I haven't said anything about proxies, have I? I've got a talk on this that lasts 40 minutes, which I could put up. It's a bit tedious, because I waffle on even more than here about how I got to this and what my approach is. But you can skip, because it's on the video, you can skip through and get rid of me waffling. But you'll find some really interesting things about Milankovitch cycles. And there's a wonderful tool from the University of Madison, Wisconsin, which allows you to create the combination of Milankovitch cycles that delivers the varying ice age interglacials, of which this is one.
Okay.
So now what we've got here is a very simple point. One, observations say there's at least 3 degrees between the Minoan period and the Little Ice Age, and that's the coldest it's ever been, more or less, this interglacial. And that's where we're taking our measurements from. And saying now is warmer than it ever was before, it can't possibly be.
Right.
Because we're only a 1 point something degrees up. This is in Greenland, a bit less at the equator, about half at the equator than it is at the poles. But it's not got to the medieval warm period. And if it was, and now I'll take you to more evidence, because evidence is what I like. Okay. If you go to Greenland, or indeed the mountains, or between Norway and Sweden, or the Alps, just now, they're finding things that are coming out of the ice that are dated to the Roman warm period and the medieval warm period, including buildings, bones, tools, all sorts of artifacts. And they're saying, oh, this is terrible, they're being exposed. But the point is, how did they get there?
Yes.
They can only have got there because there was no ice there, and there were people living there or going around chasing things and killing them, killing their overcoats, as it were. So it must have been warmer in the past. And there's a paper I just read this morning. People have been saying to me, you know, there's a farmhouse appearing from under the ice in Iceland, and what more do you want? And I say, send me a picture, and they all can't find it. So
okay.
They are fine, but what I found was they're finding lots of artifacts. I'll get there. I will actually find that evidence, because that's what I do. I've spent the last since 2008. How long's that? 14 years.
14, yeah.
Tracking this stuff down. Good. And the people. I like to phone the people up who've published the papers if they'll talk to me. And Ali will, or Ali prefers email actually. But have you seen the proxy measurements? How we get this data? How do we know what this is? Because before there were direct readings, it was before records began, and nobody knew anything, and that's what they tell you, right?
Right.
Not true. I can do this better than the guy who does a very short movie done by Jorgen Pedersen. Have you seen it?
I have not. No.
Oh, standing in front. I'll send it to you. Standing by his freezer. He's a senior. He's principal now in the Niels Bohr Institute in Denmark, and he's explaining how these ice cores are obtained. And that's the one place where I don't think he gets it quite right, but it's great. And he says, we picked a very bad experiment. We started our recordings at the lowest it's ever been. That's his point. And he said it's the same everywhere else around the world, in peat bogs, in sea sediments. And interestingly, in a lot of the places, they use the same measurement method. And it's deuterium, it's heavy water. And what happens is, in water, there is heavy water and ordinary water. And, you know, this is a bit like refining uranium-235 from 238. You can separate them, but that's not what I'm talking about. What I'm talking about is the natural percentage. Okay. So that varies according to the temperature. So if you've got some water and it freezes, it remembers somehow. I'm not an expert on the proxy science. All I know is that by looking at the proportion of heavy water to light water, you can tell what temperature the water was when it froze. Now, the models assume, if you assume that there is no natural change, and then you look at what today's change is, and say that's due to CO2, well, that's a totally false statement. Or overtly, I don't hope that's obvious, because if you would have got that much change anyway, naturally, because it's on period, on rate cycle, how can you possibly claim that that's all due to humans?
Yeah, it's absolutely preposterous that we're going to spend $40 trillion based on the idea that it didn't change until humans started changing it. Amazing. Yeah. Yeah,
and that's an assertion based on a presumption which is proven wrong. And interestingly, this is making up a vague theory. That's exactly what they did. They knew very nicely it was a vague theory, and they didn't think they'd get found out because nobody knew. nobody knew what the truth was when this was made up and sold to people in Rio in 1992, and all the idiot prime ministers signed up to save the world from CO2 or whatever environmental disaster that wasn't happening,
Right.
because they wanted to look good with their electorates. But the next thing that happened, of course, around 2000, this stuff came out. All of a sudden, here's the evidence saying it weren't like that. So guess what they did? They decided the science was settled and shut down debate about it, and started funding people to deny all this other stuff that was coming out.
So what are you thinking about? What is Richard Alley thinking himself about this?
I think he wants to keep his job. He's sort of kind of sitting on the fence, but he's a nice guy and he's very cooperative. And the one thing I have asked him, I said, look, yours doesn't look quite like the others. And none of them look quite the same because they're in different parts of Greenland where it's very extreme in Greenland. If you look at them as taken in as a whole, they say the same thing. You know, there's a declining trend, which is obvious in all of them, and it's cyclic.
Okay.
So it almost doesn't matter, because if there's a declining trend and it's cyclic, then the basic assumption of IPCC models is false and flawed. And they definitely shouldn't. And they are so deceitful, because they've just produced another one. They must have forgotten how badly. You remember ClimateGate, when they were found out plotting with East Anglia University and the awful Phil Jones about this, and they've done it again. They've just come out, and man only did it back to 1,000 years ago. The IPCC have just published their own data, which says it went back 2,000 years without varying. Absolute tosh.
So I think I personally have spent at least hundreds of hours reading the ClimateGate emails. I've spent enormous amounts of time. It's fascinating. But getting back to Richard Alley, from my perspective, it's like he dropped off the face of the earth publicly. I wonder if he's not talking as much in the public because he doesn't believe as much anymore. Because I haven't heard him say anything publicly in a long time.
I would say from his responses to me, he just wants to carry on doing whatever academic work he does, because he knows if he comes out strongly this way, he'll lose his job, the same as Peter Ridd did and Judith Curry and all the rest. If you tell the truth, you are no longer employed. This is the IPCC AR6 report. They're saying what they think what the variations have been. Now, if you look there, you'll see it's moved the whole 0.2 of a degree. And then over here is the 1850 onwards, and they just guess it. It says something on the end here. It
says simulated, natural only, solar and volcanic.
Yeah, which means they made it up.
Yes, they made it up.
So they made up what they said it would be if humans hadn't contributed to it. And this is what they actually observed. But again, of course, this is what we've observed here. Sorry, that's what we've observed here and here in the past. Or perhaps I should just go like that.
Okay.
And none of these things are hockey sticks. No way are they getting anywhere near the 3,000 year ago again maximum.
Yes.
And we know that from the observations, and they're still kicking this muck out in 2022. And it's just incredible, the fact that people will believe them. Why would they believe them? You know, it's like saying, I don't know, some miracle's going to happen or whatever. It's religion. It's not science.
Yeah. So on that right side of that graph, I don't believe that either, where they say every recent year is much warmer than any year before 1950, or the 100 years before 1950. Every single one of those years was much cooler than every recent year.
From 1939 to 1972, it cooled by 0.6 of a degree on the records that they had before NASA kind of corrected them a bit. So it was warming. It was cold from 1850 right through to about 1900. It didn't really warm up all that much. The line I drew is a very crude average, but that doesn't matter. It's an all to the argument.
Okay.
And then it rose about a degree to 1939. It dropped 0.6 of a degree, and then it went back up about a degree again, something roughly like that.
Okay.
And oh, by the way, as we'll see in another graph, when you use modern instruments that scan the whole surface of the Earth, it hasn't got any warmer for 24 years since 1998. So
Yep.
That's rather important. And the arguments against this are just fatuous, is the word. I just was looking at Hagcrux 5, in fact, because what I want to do is to plot those 3 lines, the Minoan, the Roman, the medieval, and the current warming on the same. I've seen this done by a guy called James J. Cummington in Texas. Very nice plot. He's done an overlaid all of the interglacial peaks, one on top of the other, so you can see how they differ.
Okay.
And ours is the only one that's really different, actually, for other reasons.
Okay. So
a thing called the Dryas. But anyway, what I want to do is to put the 3 warming peaks one on top of the other. And I've just written to somebody who's quite eminent to ask them if they can do that quickly, because I can't. I'm not that good at it. And I suspect that it will show, the 3 lines with there'll be the Minoan one, and then slightly underneath it, rising at the same rate, will be the Roman one, and slightly underneath it will be the medieval warm period, and slightly underneath that will be the one we're currently at. And it won't be like that.
Okay. So
you follow that? Does that make sense in your?
It does make sense. Do you run the models yourself?
No.
The group models? No. Okay.
John Christie can do that. Clever.
Okay.
That's for clever people to do.
I think Gavin Schmidt says it's 1 million lines of Fortran. I've heard that as a quote. I don't know if that's still true, but
I have written lines of Fortran.
I have, yes.
Yeah.
Not a million.
That's what we ran our. You can't tell the kids today this. We were running a control system on the KSR 33 doing the compiling. Do you remember those? And a Honeywell 516, which had 32K of core. I'll say that again. It had 30,000 bytes of core memory and a half-ton, 5-foot high, 1 megabyte hard drive.
Wow.
And it had to go back to Scotland every time the heads took a dive into the surface and cost a bloody fortune. Poor taxpayer.
Wow. Amazing stuff.
Excuse my French. It was great fun, though. And those were the days. Computers were special. I did have a job at National Physical Laboratory when I started, changing the valves in ACE.
Valves of what?
Valves in ACE. If you went in on Saturday morning, we had one of the first digital computers, and it ran on valves, not transistors.
Okay.
And they were flip-flops, which is what all transistors are, 2-state bits. And each one of those was a valve. And because they failed reasonably regularly, you sent in scientific assistants like me, an OIC, underpaid OIC, and you were given a bucket of new valves and a bucket to put the old ones in. And you just went along yanking out the old ones and shoving in the new ones.
Wow.
And then along came Juice, and Juice was the transistor computer. Whoa, rock and roll. Then we were right to the races.
Yeah.
So I was there at the beginning. Not quite solving Adolf's code, but nearly.
Very good.
Sorry. Okay. So meanwhile, as the plot thickens, I've just beaten this to death. The idea there is no change for 2,000 years before 1850 is garbage. Utter garbage.
Nice.
It's a lie they created to justify climate action, and it was discovered around 2000. And as the discoveries came, and as the discoveries about solar impacts that could cause these variations, they shut the debate down because they didn't want the truth told.
Okay. You think they discovered this around 2000, that they didn't really know it before that, huh?
Exactly.
Okay. All right.
So it's easy. This is the how much love is enough discussion. They had a vague theory, so they could make it up because nobody knew what the truth was. And all of a sudden, there's the evidence. Quick, bury the evidence. That's what they did. And that's why David Bellamy, who's a famous naturalist, wasn't allowed on the BBC again.
Yes, yeah.
Because he said, this is probably all handled by the planet. I've got a letter from James Lovelock when he was aged 101.
That's right.
I found him in a list of directors of a row of cottages where I knew he lived.
Okay.
And I thought, now I've got you. Now I have you, as Darth Vader famously said.
Okay.
So I wrote a letter to the occupier, for the attention of James Lovelock. And he wrote back to me saying he thought we'd find very little to disagree about. From what you say in your letter, I do not think there would have been much disagreement. The theory of the Earth as a self-regulating biophysical system is now generally accepted, even those few will say it publicly. He died about a year later. I was still writing back to him. So that's what Gaia, and this is the author of Gaia, right?
Right.
I just wrote to him and I got that letter back, and I wanted to write to him again. his problem was, this is advice, medical advice to those watching. Unfortunately, I am now almost deaf. The consequences of an unwise use of the antibiotic tobramycin. So basically, don't take tobramycin if you've got an infection and you're old, because you'll end up deaf.
Very
probably.
Good. Okay, good.
Sorry, did I diverted there? But life's full of interest. So
yes,
Lovelock didn't think so. Having said he thought we were messing it all up, in the end he didn't think that, and he wrote 101 to say so. So
interesting.
I'm in contact. I'm not just an idiot in my bedroom. I'm in contact with quite a lot of people around the world who are much, much more eminent than I'm. Standing on the shoes of giants.
Okay.
In the shoes of giants, or on their shoulders, or whatever it is. I'm going to take us back to the Makassar Strait, or Makassar. If you look at it, the timescales are going now from left to right instead of right to left. They were in the last one. You'll see it's going up and down. It's going up and down half as much. The variation is a degree of the natural cycle because it's half as much at the equator, and that's pretty much what happens during ice ages. Anybody who tells you, having seen this again, that what happened in Greenland is unique and unusual and it doesn't happen in the rest of the world, is talking rubbish.
Okay.
And that's clear. There are dozens of sites reported by thousands of researchers around the world, and that is also summarized by Jürgen Pedersen in his talk from the freezer.
Okay.
Which you will see because I will send it. It's great. It is the most compelling piece of video that exposes the deceit of the IPCC that you will ever see.
Okay.
But don't tell him that, because he's still got a job as well.
Okay.
And so's his wife, and they're both in acting. Do you know the Niels Bohr story?
I do not. No, I don't.
Niels Bohr famously got out of Denmark during World War II. He's one of the, he's a Nobel Prize winning physicist and was part of the Manhattan Project. And he got out of Denmark which isn't difficult to get from Denmark to Sweden, but he did. He made it across the Straits, and somehow or other, because he knew he was needed in New Mexico to build a nuclear weapon, which is what they're trying to do. And at that time, our way of getting precision products from Sweden to the UK, and indeed the Germans' way, was to fly into Stockholm Airport and fly out again. Well, it was a bit more difficult for us because Germany's just across the Baltic Sea from Sweden, right? So they tend not to be attacked by the RAF on the way. But we had to get there from the UK, flying over Denmark. So can you guess what we sent? Mosquito.
Mosquito. Okay.
It was made out of plywood and balsa wood, very well made, the same way Howard Hughes made his type of thing, but it was molded and stuff. And it had 2 Merlin engines in it. So you're talking about, at the time, probably 3,000 horsepower in a really light plane, and it could fly above anything else. The only thing that could shoot it down pretty much was the Messerschmitt 262 towards the end of the war. So it could do about 400 miles an hour, and at that height. So it would just fly over and nip down into Stockholm to pick up the precision bearings and industrial diamonds and all this stuff. So they brought Niels Bohr back in this, in the Bombay.
Really?
That's what they did. They had somebody, he was that special, and they gave him a mask, but the idiot forgot to put it on. I mean, this is a scientist for you. So they got up to whatever, 30,000, 40,000, put him in a suit, got up to 30,000, 40,000 feet, and said, Dr. Bohr, are you okay? Silence. Somebody takes a look, I think, and probably you could see into the hold. And said, he doesn't put his air mask on, he's suffocating. Oh no. Shit. So they had to go down to 25,000 feet, put their foot on the, set the controls for the heart of the sun, basically, and head for home at really dangerous height. And Niels Bohr's comment on the whole incident was, that was the best sleep I ever had. It was in the Bombay of a mosquito from Stockholm to London. And then they got him to New Mexico, where he no doubt worked with Feynman. And the rest was history. So that's the story of Niels Bohr's journey from Stockholm to London. This is the UAH thing that John Christie puts up for the Senate. I've seen him present this in Westminster. So what I'm showing now is reality. I've talked about the arguments with models, which are, is this made-up model better than that made-up model? To which the answer is, I don't really care. I want to know what's really happening. Can I check the theories that are plugged into these models by actual readings over time? To which the answer is yes, you can. And the interesting part about this is the stuff that produces the most recent data is NASA satellites. And the NASA satellites are in a polar orbit. They have a single instrument, so they make a consistent measurement all over the planet. And it's at a uniform pitch. They survey every part of the planet with the same instrument, equally at the same frequency. So guess what? That's a whole lot better. Once you've got it calibrated, you can calibrate it with balloons and other instruments. So it's not just made up. It uses microwave radiation. Once you've got it calibrated, you've got the best possible system for surveying where all the heat is in the world, which is the oceans. What happens on land is almost irrelevant. The land has very small thermal capacity. There's 1,000 times more heat in the sea. And that's where your weather and your clouds come from. And the land modifies it a bit. Up until 1979, when we had the satellite constellations, polar satellites, we didn't know what the temperatures were out at sea very well. People would measure the temperatures of the water intakes for their engines of their boats, which only went on the shipping routes between where people lived. And we increasingly got buoys, but it's very sparse. And it's not where all the energy is. Now, that is what your Hagcrack 5, which keeps getting touted around, is based on. And it's surface water temperature. It's not surface air temperature. So it's not the climate that you feel or that plants experience, okay? It's the temperature of the water. With engine intakes, the buoys that they're deploying, all the rest of it. That's what Hagcrack 5 is. Now, isn't it rather better to have a uniform set of measurement? And it's still only where the buoys and the ships are. Isn't it better to have global coverage, global density, same instrument? And that's what NASA did. It's NASA satellites that are up there, and they're being reported by, shock horror, the arch enemy of climate change supporters, the University of Huntsville, Alabama, because they have a very principled Professor John Christie there, who, with his colleague Roy Spencer, originally figured out how to do all this and found out where the problems were, corrected them. So this is the best data you can get from NASA. And what it's disproving is the NASA that the people keep putting up, which is the NASA hockey stick, which they still publish, and I already said they should be ashamed of themselves for doing it, by people like Marcotte and Mann. I don't know if they publish Mann's work as science anymore. The stuff that NOAA and NASA publish is just laughable. And I'm saying that as a scientist, okay, not as a Joe off the street. It is laughable. The thing about ocean pH changing from whatever it is, 8.2 to 8.1, or and that's making the ocean more acidic, and that means 30% change. It means they understand diddly about how the scale works. The scale is 10 to the 14 long, and it's a few thousand in that, right? So it's nothing. And it's even in the pH scale, it's 0.1 in 14. And they're saying it represents a 30% increase in acidity. And these are people who are supposed to be scientists. They're not. They're activists and editorial people with literary degrees writing rubbish. I hope I haven't understated that. So let's look at the evidence from the satellites. There are a couple of bumps on here. After it starts on the left-hand side there, you can see what the axes are. There is a bump. It goes down to start with, then it goes up. There's been a couple of volcanic explosions. Pinatubo was one of them. If you knock that out, the thing's pretty flat. This is at the bottom. The blue, the green and the blue are satellites and balloons. That's what's actually happening. The other dotted lines are the various models, and Christie runs these himself, in the computer to see what all these models on the left, top left in the box. All of those with their assumptions to see what they look like. And those are all the dotted lines. And he takes a mean of those, so that's all this 5-year averages. It says what it says, okay.
Yes.
And that's the red line. Now, it is actually what I call a Ferguson. Have you heard of Neil Ferguson?
I have. Yep.
Well, the error is one Ferguson. It's about 250% overestimate. And the only one that gets it right are the ones who actually say we don't think CO2 has much effect. There's virtually no sensitivity to CO2. Can you see the dotted line coming off the right-hand end of the balloons and satellite data? That's the Russian one.
Okay.
That's Mr. Putin's number.
Okay.
They don't believe in this stuff either. And the reason they don't believe in it is the reason you are looking at, which is the I'm go into Feynman mode now. If the observations don't support the theory, then it's wrong.
Absolutely.
It doesn't matter who thought it, what his name is, how important he is, it's just wrong. That is your CC model. It's just wrong. They're all just wrong, apart from the Russian version of it, where they assume a different sensitivity. And we can talk about why models are wrong in a minute, actually.
Sure.
I have now think I've done my best to describe John Christie's site. There is only one person, in my view, who can describe this better, he said. And that's John Christie, and he does it so much better than me. So if you want to see it done really well by the guy who puts it together and reports it to the US Senate and to the DOE and is the state climatologist and head of his department at that University of Alabama, watch John Christie's videos.
Good.
That's that slide. All right. So I'm trying to fit in with giving you segues here. Is that okay?
That's totally fine. Yep. This is all good.
I'm glad you think so. You look very young for. Are you
I'm 60. I am 60. Yeah.
Gosh, you're looking good on it.
Oh, thank you.
A young. I've said to Doug, he's a very young 60. He's only just retired, so he'll be around for longer than we will. We should make sure.
I don't know. You never know.
We should make sure you get this stuff.
Okay.
You know, because the important thing in science is that no one person really changes anything. It's always building on the shoulders of what others do.
Oh, Doug has his sons working on this, doesn't he?
Yeah, well, one of them does. Brian does. I'm not just. They both are involved. Yeah.
Good.
Brian was also in touch with the UK DCC. They're now called the BEIS. They keep changing their names to protect the innocent, of course. So, you know, every cock up they make, they change the name of the department. So we talked about basically the models are wrong because they're wrong model. We haven't talked about why they're wrong models. That's the thing, isn't it? I've gone on and on about what the evidence actually shows.
Okay.
So the evidence shows there were warm periods in the past. They're probably much like now, and this is the coldest one we've seen in 3,000 years. If you plot the models against what's actually happening since 1979, I'm not sure I did say 79, then it isn't happening. So what more do you need to know in basic? So what you actually need to know is just how daft these models are.
Okay.
Shall I have a go at that?
Absolutely. 100%.
Oh, well, you can compare my bullshit with other people.
Those Heartland conferences, I don't know if you've been to any of those Heartland climate conferences, but they're really good.
Yeah. Well, one of the people I haven't met him yet, but who's on the GB news station is Mark Stein.
Oh, yeah. I like him. And
Mark did that wonderful talk about being sued by Michael Mann. I know you've seen the video of that. Yeah.
I don't know if I've seen the video, but he has a book, a disgrace.
There's a great video. There's a great video. You look it up and you'll find it.
I will. Okay.
It's him addressing the Heartland conference.
Oh,
about being sued by Mann, him and Tom Ball.
Okay.
You know what happened there?
Tim Ball. I don't anymore. Tim Ball got sued. They said that Mann should be in a state pen, not Penn State.
Yeah, that's absolutely right.
Yeah, okay.
But the thing was, where it went to in the end was after loads of messing about. He was trying to shut them up, man. There's a law in the States which I can't, which stops you from doing that. There are laws. It begins with an S. I can't think what it's called.
I don't know. Yeah.
To stop people from this practice of shutting people up by suing them.
Okay.
And what happened in the end was really it happened in Tim Ball's court, but the end with Mann as well. They asked, the data became a matter. What's the word? Not a matter of interest. It became a key turning point.
Okay.
You know, was this actually rubbish? This data, had it been manipulated? And Mann was asked to present his data to court, and guess what? he declined to present his data
Yeah.
to court. And so that Tim Ball's case just collapsed, and against and Mann's one, sorry, the Stein one went away as well.
It went on for years and years. Then it was Stein.
Yeah, because they were trying to shut Mann, and there's so much money behind this fraud.
Yeah.
I mean, there's Rockefeller's money. There's what's the other one? Getty money.
Okay.
The Kennedys support it. Bloomberg support it.
Yes. Yeah.
All these useless children of good people who've got a lot of money,
oil money, a lot of it,
just want to keep it, and they don't want to share it with anybody else. That's the bottom line, but that's another story.
Yes.
I'm now going to talk briefly about models.
Okay.
When you think you know that these guys are running these models correctly and everything's included in them, which you would expect, the first thing I'm going to tell you is it isn't. Okay. Effectively, what they have is a huge global system with massive corrective effects. And I'll tell you first what the corrective effect is, because it's so important. For 500 million years and more million years than that, that's stealing Feynman from the Rogers inquiry, more million years than that. We've had a stable, relatively stable 10 to 15 degrees within 300 degrees planet. There's a very simple reason for that, and that is the natural feedback of the oceans. And what happens is, shall I get my world?
Absolutely.
Soon you will all be mine. I haven't got a cat to start cats. So here we are. Most of this is blue. 70% of it is blue, and that's where all the heat is. 1,000 times more heat than the land, which doesn't really matter as far as the climate is concerned. When the sun shines on it, it gets hot and it evaporates. That transports a massive amount of heat to the troposphere, about 100 watts per square meter, in what is called adiabatic convective equilibrium. Don't even think about it. It goes up whoosh really quick. And because it's colder up there, because it's getting nearer to space, and that's another, the lapse rate is another story. It's nothing to do with the greenhouse effect, very little. When it gets cold enough, the water condenses, gives up the latent heat, which is a huge amount of heat, which as radiation, which then goes off through the stratosphere to space and cools the oceans. But the other thing it does when it condenses is forms clouds. So the hotter the water gets, the more evaporation you get, the more clouds you get, which reflects the sun. And that's it, ladies and gentlemen. That is all the planet needs to keep itself stable. It needs to be covered 70% in water. And it's been really happy with that ever since it got covered in water. And how it got covered in water, of course, is a whole other science, but we'll sort of accept that it was. In fact, it was almost all covered in water at one point with no ice at either pole.
Okay. All right.
And
is this related to Lindzen's iris effect, or unrelated to that?
I have no idea.
Okay. All right.
But he's much cleverer than me.
Okay. I'll have to look that up. Okay.
I'm sticking to basics because I understand basics. I'm an engineer. Good. That's the real. I don't give a damn about the little fiddly bits if I know that the little fiddly bits are taken care of by the big bits that keep it. This is taken care of a big asteroid. Where did it go? Going there in the Yucatan Peninsula. It's taken care of massive explosions, supervolcanoes in Yosemite. I know it's Yosemite. Not Yosemite, actually. Yellowstone, right?
Yellowstone. Okay.
If you want to see a really cool piece of geology, ladies and gentlemen, remember you heard it here from Brian Catt. Go and look at the pictures of the Snake River Valley Basin, which is literally where the Yellowstone hotspot has melted the Ridgeon Basin mountain ranges as the North America has moved over it. And there are calderas all the way along it. That's why it's a big flat plain, the Snake River Valley Plain. It's because there's a big hot thing that was just underneath the surface and melted all the mountains down.
Really? I did not know that.
That's a bit geology.
Okay.
Geology is fascinating because geology tells us one of the great rules of geology, and it's worth always thinking back to this, is that the future will be pretty much like the past. Although the best guide to the future is the past.
Okay. All right. Good.
Okay. So there we are. We've got our control, dominant control. Within this, we're talking about 100 watts per square meter of convective stuff cooling the oceans, and probably the estimates I've seen about 50 watts per square meter of control from the clouds, 150 watts altogether. per square meter against the incoming 240 that actually get inside the Earth system. So that's a lot of feedback.
Okay.
Now we're talking about a one, possibly, if they're right, even the oversensitive models, we're talking about 1.5 watts per square meter of greenhouse effect, really.
Okay.
And now, when they calculate these radiative effects, they do it blue sky. Even HAPA does it as a blue sky calculation, because they don't understand the clouds. They can't model the clouds. If you ask the IPCC, they'll say, actually, we can't model the clouds that way. It could be less, could be more. And they mutter about high clouds. Oh, well, yes, the lower clouds probably reflect, but the high clouds will make it more. And this is Feynman's muggles. He says you could say, well, I don't know, it's probably all down to muggles. And so it's just making it up as they go along. But the point is here, they're not allowing for the feedback. So it could be net zero, literally.
Yeah.
You could have 1, 2, 3, 4 watts per square meter of greenhouse effects, and the planet comes along and says, not today, thank you, we'll have some more clouds. Bunch, gone. They're not creating, they don't understand climate systems, but they don't understand how a model really works, what the transfer, and they're not including all the transfer functions. What they're saying is, we've got this great big system, and we'll waggle this tiny little variable inside it, assuming everything stays the same. And we'll say, if we waggle this, then that temperature change is due to this little waggle we did, with all these huge things going on around it that they don't understand properly. Now, if I'm keep stealing from Feynman, some of these, because these quotes are so timeless. If you say that we can't model the clouds very well, you don't know anything about the model, because the dominant control effect is not properly considered in your calculations.
Yeah.
I think I'll make my point and end there.
Very, very good. So
have I made sense to you?
You have absolutely made sense. I was just, as you were saying that, I'm thinking in the future, they have this idea of what's going to happen with the CO2, and it causes increased water vapor and positive feedback. But there's no evidence in the past, as we look at what CO2 has been and what the temperature has done, there's no evidence, is there, that CO2 is the climate control knob? I think there's not.
Oh, well, how can there be? So let's talk a little bit about CO2 as causal. Now, the best thing I can tell you in my experience of this is, I also looked at I've written a paper, which I will promote slightly, about whether submarine volcanoes cause interglacial events, because varying insolation from the sun in an eccentric orbit can't. Over the year, it's warmer some of the year and colder the rest of the year. We're going to talk about some carbon dioxide briefly, and whether it is causal or whether it is simply an effect of change. This always makes me smile, because I am also doing a paper, or I have done a paper, it's pre-pub. Very hard to get things published that don't say carbon dioxide causes everything. As you'll find if you write a paper and try and submit it to a journal for that, saying actually this isn't CO2, it's probably, and in my case I'm talking about submarine volcanoes warming the oceans during the interglacial period, and it being actually excited by the maximums in solid gravitational tides, which means what you get here is planetary twerking.
Okay.
The thing has 3 different frequencies going in it: obliquity, precession, which is the wobble, the obliquity, the actual change of the angle, plus its eccentricity. How about that? I love it. Now, if you put all those 3 things together, you're going to get the Earth twerking around more than it does normally. And actually, if you look at what I've done, is worked out how much volcanic material is coming into the oceans from, again, from data that's been gained since 2000. Before that, it was denied. Volcanoes had nothing to do with anything. There was nothing coming out of them effectively under the sea. It doesn't matter, because we don't understand it, so we'll ignore it, and it might upset our results. So I spoke to a guy when I found out that indeed there are massive peaks involved that's recorded in the number of emissions, volcanic emissions around the Pacific Ring of Fire during the period of an interglacial warming, the 7,000 years up until 10,000 years ago. And I asked in the paper this was written. This guy, there's a guy in I don't know, Harvard, Peter Hybers. I phoned him up and said, "Why have you written what you've written?" What he'd written was, "We think that perhaps this well-known increased volcanicity that occurs at this time is caused by climate change."
Okay.
So I said, right, so we're thinking this increase in CO2 or whatever it is actually making the whole planet more volcanic, is it? And the atmosphere weighs whatever it weighs, a fraction of the weight of the oceans, and an infinitesimal effect on the solid mass of the Earth. How could you possibly say that? And I think the answer was along the lines of, well, it's not the right thing to say at the moment. It's just nonsense. So cause and effect are very important, right? And at the moment, CO2 causes everything. But is that the case? And the answer is, well, probably not. Because if you look at the evidence, you find something quite different. And the evidence, and people get excited if they don't like this story, because it's supported by the observations, and they really don't like those. If you look at the evidence from the ice cores to do with carbon dioxide, they found that it lags by possibly hundreds of years. The carbon dioxide lags the change in temperature. So the temperature goes up, and then the CO2 tracks along after it. And then then the temperature falls, and guess what? CO2 keeps on going up because it doesn't catch on for a bit. Now, what's that to do with? Oh, surely you must be making it up, Brian. Well, no, it's just physics. It's called Henry's law. And Henry's law states that the proportion of gas in a liquid where the surface is in equilibrium is proportional to the temperature. And as it gets hotter, more of the gas is released into the atmosphere. Okay, so that's it. That's Henry's law. So that's always going to happen. And 2% of CO2 is in the atmosphere. The other 98% is in the oceans. So if you want to get this 2% up to double, you have to double the amount in the oceans. If you see, I mean, it just doesn't work like that, is the short answer.
Okay.
And it lags. It's not a cause, it's an effect.
Okay. So do you think that the rise of CO2 that they're seeing in the Keeling curve, could that be because of the warming in the medieval warm period with the 800-year lag, or no?
Or it could be to do with the warming that's going on now. It's
Okay.
certainly some proportion of it is. And anybody who's watching who doesn't think that's true can just go and look up what that is for, how many grams of CO2 per cubic meter or whatever it is. It will be kilograms of CO2 per cubic meter or micrograms, whatever, right?
Yes.
There is at a given temperature. It's a well-known relationship. I've got a table on my computer that hits somewhere. There's a table showing what it is. So this isn't anything that's unknown to physics. It's a very well-known relationship, and it applies to other gases as well. It applies to all ideal gases, I think, of which CO2 isn't one actually, but it's close to it in effect.
Okay. Another question is, there have been some chemical measurements of atmospheric CO2 in the 1800s that were like 400 plus parts per million. I don't know if you have any thoughts on whether those could be correct, or are they wrong?
I've had enough thoughts already. No, I don't. What I did read, I've watched William Happer talking about, when you're talking about measurements, and I'm really answering the question by saying I don't know how good these measurements are, but I'd rather trust the more recent measurements.
Okay.
But what Happer was saying was, if you go out into a cornfield, I mean, this is an American one, using type 3 photosynthesis as distinct from the rubbish photosynthesis we get up in north.
Okay.
Have we talked photosynthesis is a whole other story. It's half, CO2 is down to half the level.
Yes.
Because the corn, it's during the daytime when the sun's shining, it's really getting eaten up there. So you've got to be very careful how you make measurements is the short answer. But that's an interesting factoid I thought I'd drop into the conversation.
Yeah, I think Happer said that in a growing cornfield, it might be 420 parts per million, and hours later, it might be 200 parts per million. Same field, a few hours later. Yeah.
Absolutely right.
Yeah.
And if you pick up Happer talking about this and photosynthesis in general, he's got a talk on YouTube. I forget what it's about now, but what the original subject. Yeah. But he also talks about photosynthesis, and one of the important things about photosynthesis is it doesn't work very well at 400 ppm. It's not enough CO2. The pores have to open too wide, and they let a lot of water out. They get rid of a huge amount of water to perform photosynthesis, whereas at about 1000 ppm, which is about optimum, what they grow fruit in greenhouses at, pump CO2 in.
Yes. Yeah.
At 1,000 ppm, the pores don't have to open so wide, so they can absorb enough CO2 to grow themselves, and without losing so much water in the process. And that also means that we've got a 30% greening on the planet as a result of the increase in CO2, probably. And that is making plants on the margins of deserts improve. Basically, agriculture's more, what's the word, more possible. I can't think of the right word.
More productive or more?
Yeah, it's less threatened, less marginal. Yes. Okay. On the edges of deserts. Yeah. So basically everything, I think Alex Epstein said, or Epstein, I don't know what we call him.
Epstein, I think, yeah.
Epstein said this. He said everything about what you are told about climate change is about 180 degrees away from what is really happening. You are being lied to.
Yeah. I do think that Doug Lightfoot just earlier this week, I think he said that the additional CO2 that we put into the atmosphere has increased global crop yields on an order of 20%, something like that.
I wouldn't doubt it. I mean, if there's 30% more green, then why wouldn't 20? I did see what Doug wrote. He's saying it's making, I don't know, he said millions or billions of dollars for people.
Okay.
Because agriculture is so much more productive.
Yes,
it's making a lot of money for farmers. But they want to stop that. Anything that works, they want to stop. And of course, the reason is they want us all to give up our cars, live in 15-minute cities. But the best quote is it's attributed to David Rockefeller. And he said, the oligarchs probably only need 500,000 slaves to serve them. The rest are just consuming resources pointlessly.
Yikes.
So we better herd them all into cities and not have 50% of the earth. And this is UN Agenda 2130.
Yes.
Half of the earth is going to be banned to humans. Oh, except to elites, of course.
Yes. Yeah.
Inaccessible. Yeah. And you won't need to leave your cities, and you won't be able to because you won't be able to afford a car by then. Etc. 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 It's all based on a whole, what's the word? A tissue of lies.
Yes. Yep. So do you have thoughts on where this is going in terms of how much longer can this scam stand up? Any ideas?
Well, as long as the government, as long as we vote in politicians who will support it. And the problem is this is what the state does. The state has used taxpayers' money to fund the creation of bogus science and promote it in the media. And it's being promoted by people who couldn't work out their change at the movies. Literary arts graduates and journalists with literary degrees. The person who wrote our Energy and Climate Change Act, when they were really Blair pushed it through really quickly because they could see that the truth was coming out in the observed data, from the satellites and from the ice cores and all of it. So he got this guy, Ed Miliband, who's another arts graduate, PE degree idiot, to organize it. It's created the Department of Energy and Climate Change, and they got in an expert to write the Energy and Climate Change Act. Brian E. Worthington, an English literature graduate and Friends of the Earth activist, wrote the Energy and Climate Change activist, which determined our energy policy.
It's mind-blowing.
Mind-blowingly stupid and arrogant. And they all stood up and voted for it. What are you going to do? That's your system. So the problem is you have to break that system. So actually, it's the political system. While the political system, I can send you some other stuff from Yes Minister, which you may have seen in America or may not have seen.
Probably not. Yeah.
No, I'll have to share it with you because it's absolutely perfect. The head of the civil service explaining to the head of a department why the politicians will never allow this to change.
Okay.
Yeah.
I think there is a picture, a photo of maybe it's Ed Miliband and maybe Carolyn Lucas, and they're standing up and applauding Greta Thunberg. Greta's standing there. Yeah. They're applauding the great Greta.
The idiot. Yeah.
Amazing. Before I forget, what do you think actually will happen with the global temperature between now and 2050? Any ideas which way it's going to go?
I think I know.
Okay.
Oh, cool.
Okay.
And have you talked to Carlos Weiss yet?
I have not. No.
There's a paper, and it's famous amongst activists because it's called, they even call it LW17. Now I get the chance to enter stage left with the guitar. It's not a real one.
Not a real one. Okay.
It's a Tanglewood. So here is, oh, actually, this is tuned. This is Keith Richards tuning. This is tuned to an open E.
Okay.
So you don't have to hold it down any strings, right? You can just go.
Nice.
Easy, right? So the point being here, so if I were to go, that's what I mean, let's say there were 5 orbital periods on the Earth.
Okay.
Or indeed, with Ludica and Vice's case, they were looking at solar wind peaks.
Okay.
Frequency peaks. And we know there are such things. So obviously you can't see them individually. So how do you find them? And you do it by a thing called spectral analysis, or Fourier analysis is one form of that. Okay. So if you, and they use this to find out, to detect the 100,000, 41,000, 23,000 peaks in the Ice Age cycle. That's why they're not 100,000 dang, 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 right? Because there's three different frequencies combining. But how do they know that?
Okay.
The Irishman famously said, how do they know? And the answer is, if you do that, you've got a bit of maths that you can apply, which says, oh, actually, in there, I can find, that's out of tune. And it will do that for you. Okay. So you run the routine. So you take your temperature data series and you say, computer, frequency analysis on this temperature series. Okay. And it goes whir, crunk, crunk, and this is very well established. And there are people argue about the details of the methods and what the limitations are. Blah, blah, blah. Don't care, because they come out with that one. They do a power spectrum. So you get ping, and that's your first note, and ping, that's your second note. Okay. Ping, like spectral analysis when you look at a star or something. And put that away now. I could have bought the amp as well, but I thought too much. That's good. But you got the idea, do you?
I got it.
So that's how it works. So what the answer to, and I haven't forgotten what I was saying, what Ludica did was he did that spectral analysis on a composite of about 10 different time series, tree rings, ice cores, etc., etc. Okay. It's all in the paper. And what they found was they had a peak. Well, they had several peaks. And again, I'm not the expert on this. What they chose to do was to say, actually, we think the dominant peaks here are 1,000, in round numbers, 1,000 years, 500 years, and 200 years. And there's actually another small one around 60, which is significant. Okay. And if you wrap those, then he said, right, now let's bang them back together. And because this is empirical, it's not made up. Okay, that's okay. He's got natural frequencies out. Okay. Of the chord, and he's putting it back together. So he's done a play as you go. Play in a day type music book. So if you hold down those chords there, then you'll get the same thing. And sure enough, you do. Okay. And guess what it does at 2010, 2015? Cool. I don't know. It goes down again. Okay. Because that's what it's done. And I refer you to an answer I gave earlier, or said earlier, which is the past is all pretty good. It's probably the best guide to the future. So all the indications are that if we are on the natural cycles, as it looks like we are, then the next trend is down. So let's just talk about this one quickly, okay? Okay. What this is the satellite data for what it says, low air temperature, land plus ocean, so that's the whole world. The lower TLT is something lower troposphere. Have you ever seen Richard Feynman giving evidence to the Rogers inquiry?
Yeah, that sounds familiar, but I couldn't tell you. Don't know.
Well, they had the rubber seals that blew out of the...
Oh, yeah.
And did you remember what he did with it?
I don't. What did he do?
He was asking the NASA guy, he said, basically, you knew these rubber seals that gave way in your whatever SRBs, etc., that there will be some temperature at which they'd lose their resilience. And yes, yeah, you knew, and the guy said very clearly, we did, and the indications were that it would all be nominal at that temperature. Okay. And Feynman leaned forward to a large glass of ice water he had in front of him, and he said, well, I took this piece of rubber stuff from the seal that you gave me, and I put it in this ice water here in a clamp. And he took the clamp out the ice water right in front of the Senate committee.
Really? I don't remember.
And undid it, spun it off with his hand. And he said, I think you can see that, and this is where I got this expression from, for a few seconds, or a few seconds more even, and he handed it over to his colleague, this would have had no resilience. I think this has some importance for our problem.
Wow, I did not remember that.
You lying bastards, you killed them all because you weren't prepared to.
In the cold, yep. Shouldn't have launched in the cold.
And that was the end of it. We haven't talked about energy yet.
Yes.
Well, yes, we have at the beginning. I did talk about energy at the beginning, yeah. Okay, well, this is easy to cover.
Let's do it. Okay.
So if you ask me, what do I think is going to happen next? Then I'd refer you to the answer that Ludica and Weiss gave earlier, which is that there are natural cycles. And those natural cycles, which you can detect in the proxy data of the last few thousand years, are 1,500, 260 years, different so that's the summary of what I've been trying to say with the guitar example.
Okay.
Now, if you recombine those frequencies and look forward, what you find is a decline. It basically says this is the peak. This is not a hiatus. It's not a leveling off. It's actually a turning point.
Okay.
And it will go back down, and it will get colder till 2,500 or whenever, and it'll go up and down while it's doing it. It can go up and down almost the whole amount of the range during the process as well. It's not a smooth curve. And guess what? Around about 3,000 years from now, it'll be warm again. And everybody will be surprised again, because humans don't live long enough to know what is going on. So the thing here is the data from the global satellites. And what it says is, look, guys, in 1998, there was the last El Nino that really increased temperatures and kept them increased. Well, it didn't really, but that had been the trend from 1972, after the cooling from 39 to 72.
Yes.
Then you had the warming up to about 1998. And the last one, if you look at that, the range of the 1998 El Nino was what, minus 0.4, a whole degree.
Yes. Yeah.
That's the whole warming that we're talking about. Then it dropped back down to nearly the whole amount again.
Yes.
And it's not really managed to get past it since. Up until then, El Niños have been successively warmer, and in the same way that each of our medieval warm periods has been successively cooler. But this isn't happening now. From 1998, you'll see there was one in 2009, which didn't quite make it.
Yep.
2016 was fractionally warmer. But we're looking at what, 0.05 of a degree?
Yep.
And since then, it's gone down by 0.3 of a degree. So I would say, Guy, and all the time that's been going on, that pink line is the CO2 going up and up, which I would suggest is in response to the ocean warming of the last 30, 40 years, to 70, 50 years.
Okay. Yeah.
And why wouldn't it? So you would expect that to happen.
All right. So it's not necessarily an 800-year lag. It can be a much shorter than 800-year lag of the warming to the CO2 coming out.
Well, yeah.
Okay. All right.
Do you know what? If you talk to John Christie, he'll tell you one thing for sure. We really don't know how this thing works.
Yes.
It's very complicated.
Yep.
What we do know is, and this is me going back to empirical, Brian, there's oceans there that make clouds that make sure it doesn't get out of hand.
Yes. Yep.
They are the control.
Yeah.
Greenhouse gas, this is a tiny effect. It's a watt per square meter or whatever it is. It doesn't matter, and it's probably entirely negated. It's net zeroed by the natural feedback of the clouds. So whatever it's doing, does it really matter? No. Does it affect the temperature? Does it control the climate? No, it lags the climate. The control is the oceans. Does it control the lapse rate from the troposphere to the ground? No. That's the barometric formulae, which every climatologist knows, and they had to form climate scientists to deny. Because climate scientists don't seem to know diddly about climatology and physics. It's basic thermodynamics. I talked about adiabatic convective equilibrium at the beginning, didn't I?
Yes. Yep. Before I forget, What do you think is the magnitude of the cooling that you see between now and 2050?
Oh, not a lot.
Okay.
half a degree.
Okay. All right.
The prediction actually is, the Lydekker and Weiss prediction is that it'll fall to 2050, and then that will be the first time it comes back up again.
Okay.
And all that is what happens if you combine those frequencies, you know, that are interfering with each other. You know, so they might interfere constructively, or they might interfere.
Yes.
And if you want a perfect example of that, I love this one. Shall I close with this?
Sure.
There's the last interglacial was called the Eemian. And the Eemian was 4 degrees warmer than this interglacial. So 6 degrees warmer than now, 130,000 years ago, when humans were well around and presumably hunter-gathering happily, just like they always had been, till they learned how to farm and put wheels on things. They've been trying to take them off with top fuel dragsters ever since, but there you go. I love top fuel dragsters.
Okay.
And the boats are even better.
All right.
So where was I? I got distracted by
the Eemian? I don't know. Did you have a graph of the Eemian? Or, I don't know if you have a graph.
Yeah. Well, yeah, no, I can. You write it down and I'll try and find. Right. Yeah, of course I do. Yeah, I mean, I've got a whole talk on it, which I can send you the video link to. Okay. Sorry, yeah, the link to the video.
Sure, sure.
Now, the point about the Eemian was we had the business where the Earth warmed up for 7,000 years. And what actually happens is when the tropics start to saturate, this is just my obvious conclusion. I've never seen this written down, but nobody ever argues with me, not even activists. During the Ice Age, the glacial period, nowhere in the Earth is at tropical weather conditions. The atmosphere is not saturated anywhere.
Okay.
As it warms up, that 5 degrees at the equator, roughly, I think they've measured in Brazil. Okay. And most of the heat is exchanged in the tropics. The poles are just a side effect, really. The heat is transferred from the tropics to the poles. Half of the heat that falls on the Earth falls between 20 plus and minus 25 degrees.
Okay.
Warms the oceans up, and they keep evaporating until they hit saturation. Okay. And I mean, they really, really get going. Once the oceans get to about 28 degrees, John Christie says that's probably about as hot as it can get, because not only are they evaporating like stink, you know, there's so many clouds coming off to reflect the sun where the heat is greatest. The radiation from the Earth also goes up by the 4th power. Okay. Right. I mean, that's enormous. So you're losing heat at a much greater rate, and the atmosphere is saturated. It's losing a lot. It's doing a lot more evaporation and cloud formation now. Okay. But it's still getting hotter. And the reason it's getting hotter is because all 3 cycles of orbital forcing were in phase for the Eemian. They're not for this one at all. Okay. So you had eccentricity in phase, the 41,000 in phase, and the 23,000 precession in phase. Bang. So the Earth was, and according to Brian's theory, the Earth was really twerking, right? Okay. All right. The stuff really moving. Okay. The volcanoes popping off all over the place. But how could it lose the heat? Because it's already saturated the tropics. Well, there's only one thing to do. If you can't get hotter than 28 degrees, you expand towards the poles. Okay. And not a lot of people know this, but probably you will find people in Canada or two. Yeah, we got that too. They had, similar thing. We found the remains of hippos as far north as Leicestershire in England. Okay. They lived in the Thames. We had elephants, hippopotami, and cave lions living on the banks of the River Thames when it was still 50 degrees north. Okay. They can't live in a temperate climate because they haven't got enough body fat. Okay. So it was tropical in the UK. So that's how powerful the differences can be, just by the way that the cycles combine differently. Ours is a runt of an interglacial, of a warm period. It got completely stuck. Its eccentricity component is minimal. Okay. And it got hit with a thing called the Dryas. And I will leave you with this thought. There are viewers, answers on a postcard. What happened in the Dryas was, and you'll see this in the graph that I send you, which shows the overlaying, 4 overlaid interglacial periods I mentioned earlier by James Covington.
And there was a massive drop. It started to warm up until for about the first 3,000 or 4,000 years of the warm 7,000 year warming. And about 14,000 years ago, it went bam, straight back down to glacial temperatures for about 2,000 years. And then it popped back up and it struggled, and then it joined on with the forms of the other interglacials.
Okay.
What caused that? Nobody knows. I suspect the most likely thing is some serious collapses of calderas or volcanic structures. There's obviously a lot of volcanism going on during that phase. But the reason I think that, again, it's me again now, this is Brian's theory, is because if you look at the sea level rise for that period, it starts off down here 17,000 years ago, and it keeps going up, 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 all the way to 10,000 years, and it doesn't even pause when the temperature, from 14,000 to 12,000 years, the temperature's gone back to glacial. The oceans rise 130 meters, during that period, and they didn't bother stopping for that 2,000 years. So where's the heat coming from?
Interesting.
Because the temperatures that you measure that are in the ice cores are obviously the temperatures on land. You can't have a record of the water surface temperature. It's just not a practical thing to do. So what could it be? The doctors of science future out there, how come the oceans kept rising 130 meters through 2,000 years of glacial temperatures without even batting an eyelid? Where did the heat come from?
I do not know. Okay.
You want to know what the answer is?
Sure.
It's underneath you.
What, in the crust? No?
Yeah, coming into the oceans from the volcanoes, because they're heating the water up. There's enough heat there. It's 10, even on the most conservative estimate I can do, it's 6 times 10 to the 20 joules per annum. It's a lot of heat. I've stolen from Feynman again. That's one of his lines. It's a lot of heat. So there isn't anywhere else the heat can come from. Somebody tells me, please, where it is coming from. That would be great. But I can't think of anywhere else. If the surface of the Earth dropped back to a glacial temperature for 2,000 years, how come the oceans kept rising? What made the oceans keep rising?
Okay, so the oceans got warmer as the land got colder for that time period? Is that what happened? Did they get warmer or retain their heat at least? Yeah.
This is a Monty Python moment. Yes.
Okay.
This is my theory, which is mine. But
Okay.
yeah, Anne Elk, you may not know the sketch, but yeah, absolutely would have to. The oceans would keep warming while the land was cooling. Yes.
Okay. All right.
Because there's no other explanation for the conflicting data. And I can send you why don't you write down, send the sea level rise graph.
Okay.
Yeah. It's very well known. Even Judith Curry just told me it was public domain offhand. So she knew immediately what I was talking about. So I think it's what do you call something that's it's in common circulation and nobody disputes?
Common knowledge? I don't know.
Well, there you are. That'll do. Well known.
Okay.
It is well known.
Okay, so I guess throughout time, then we don't have to assume that the oceans and the land move in lockstep. Even for long periods of time, they can go in opposite directions. I did not know that.
Yes.
Yeah.
But only during, the only evidence that I have, you may think that, but I couldn't possibly comment because the only evidence I have is what I know from the Dryas period.
Okay. All right. Okay.
Yeah, I tried I try throughout to maintain whatever I say about climate science. What I try to say is what I know and I can support by observation. And if I can't, I won't say it. I'll say I don't know.
Okay. All right. All right.
Because that's how we do it. And one of the things about engineers that academics don't get, and that is we have to make things that work.
Yes. Yeah.
So we can't have aeroplanes or bridges or skyscrapers that are built because we think that's about right.
Mm-hmm.
Because they tend to fall down and this is bad and people die.
Absolutely. Yeah. Yeah.
So if you're an engineer, you really, really, really believe that, you have to know, you have to observe, you have to be able to prove something before you can build it. How do I make one of those?
But very, very good. This might be a good stopping point, do you think? I think this has been really, really good. I know I'm going to get a ton of good clips out of here, and I would love to have you back again some other time if you have any more time to record some more stuff. But this has been a big honor for me. Thank you.
Does he ever stop talking? Yeah, that's fine. I mean, there's so much stuff. The subject is so huge, but a lot of it is detail.
Mm-hmm.
A lot of it is very obvious.
Mm-hmm.
And the people who come up defending what is obviously indefensible are legion. It's like, in the old days, the hordes throwing themselves on the walls of the castle with no bloody idea what they were fighting for.
Right.
I just don't get it. So I think I think you'll find most engineers, if you ask them about energy supply, will say, well, it's nuclear and it's obvious.
Yes. Yeah.
And it would be stupid to heat with anything other than gas, because you can burn it at 93% efficiency.
Mm-hmm.
Why would you burn it in a power station to make electricity at 60% efficiency and put it in a heat pump that doesn't really work very well and is very expensive and uses a lot of resources? It's just nonsense. They say, oh, we'd be powering it with renewable energy. Well, no, you won't, because it can't. Renewables can't power the grid. There's not enough energy, and it's a weak source.
Right.
So you can't get enough energy to power the current grid, never mind the 3 times the tripled grid you'd need to charge up all these mythical batteries and drive all these heat pumps. The electrification of energy supply is a complete nonsense when you don't need to do it. And coal's okay, actually. If CO2 isn't a problem, if you scrub your chimneys and look after the cofferdams that you keep the waste ash in, which they didn't do very well in Tennessee Valley Authority very much. Why not? You need the only alternative to having cheap, plentiful energy is poverty and regression. Now, have you seen what's been written by? He's actually a friend and colleague from early days in this. John Constable.
I've not read it, no.
And another prof from New Orleans or somewhere, Florida, sociology prof. But he's been involved in this from very early on, and they're just making it absolutely brutally clear that if you follow this nonsense, you are supporting politicians deliberately pushing you back to before the Industrial Revolution by law.
Right.
Yeah, some kind of dystopian post-industrial society ruled by elites who control what you can do and what you can't, and how much energy you can have, because they want it all.
Right. Yeah. So the stakes here could not be higher, hardly. I don't think the stakes of how we're going to power the world. Yeah.
Absolutely not. And it's dead simple to know what to do. The problem is, in a democracy, the totalitarian regimes have no trouble figuring this out. I mean, the Politburo of the Chinese nation is 50% technically educated.
Okay.
They're
not buying the climate scam, are they?
Well, no, of course they're not, because the whole point is they're the ones who win from it.
Okay.
And what part of what this paper about, the one I just mentioned to you, is how much our energy use is back down below 2000 levels. Because China not only controls all the raw material production in the world, the refining and production of raw materials, they get it from other places, but they refine over 50% of almost everything in China.
Okay.
They control a huge chunk of the manufacturing. I circulated a dynamic thing on how they've overtaken the USA and everybody. So everybody else is client states, because their governments have forced them to be by denying them cheap, plentiful energy, which is what you actually need to do the job.
Yes. Yeah.
And the only places who've got this are the ones who aren't doing the stupid things.
Yeah.
But anyway, that's the point. It's absolutely, the stakes could not be higher, because democracy is the thing that's at stake. Have you seen Carl Sagan predicting this?
I don't think so.
He died of cancer quite young, unfortunately, like Feynman, about 65. But he's saying, basically we have a situation where we have a totally technology dependent civilization.
I did see that. Yeah.
And barely anybody understands. Most of the politicians can't even do joined up numbers, and it will just take one charlatan to come along and exploit this system and the whole thing will go to hell in a handbasket. And that's exactly what's happened. The charlatan was called Maurice Strong, and with David Rockefeller's money. So there you go. And if people don't actually understand that the people who govern them are a load of useless, power-mad, egocentric nutters who don't understand anything they vote for, but will do it because they want to stay in power for 4 short years or 5 short years and get some nice, easy jobs afterwards from the people they've empowered to make a lot of money.
Right.
Which is what happens. These guys, our ministers in the UK, who passed a lot of these laws, all went off to jobs as directorships or consultants to the very large energy companies that profited from all the renewable subsidies.
Right. Yeah.
The guy who went to jail for lying about driving his car, tried to get his wife to take the points, Chris Huhne, was the energy minister, and he signed off on wood chips being burnt in Drax. And wood chips shipped in from Louisiana, for which they get $1 billion a year in subsidy, right?
Crazy, yeah.
And before he came out of jail, shortly after he was sentenced, he was appointed as the European chairman of the wood chip company's operations.
Okay.
Now, you can't make this shit up.
You can't. Yeah.
It's totally corrupt. But
Yeah,
the answer to the big question is it's a turning point. If the past is a good indication of the future, it's going to get cooler to 2050.
Okay. Yeah, I think we have that turning point. I think the people are waking up too. I think the scam is, I think a lot more people I see online are pushing back. They're understanding the scam better and pushing back harder. I'm feeling optimistic about that part. We'll see I hope I'm right.
I just don't know how you stop it happening again.
Right.
The UN is responsible, of course, and the W, but basically the elites with the UN. Maurice, have you seen why Maurice Strong talking about why he went into the UN?
What, if they need an enemy to unite us? That part of it? Was it?
Sorry, the what?
I thought he was talking about we need a common enemy to unite us, and global warming fit the bill. Maybe someone else said something like that.
Oh well, yeah, that's one of the, that's well, he probably could have done, but what he wanted to do was to impose the will of Rockefeller and himself on the world.
Okay.
You can't do that as an elected politician.
Okay.
So what they did was he realized that if he could get himself into the UN, where he was suitably introduced and funded to do, which he was by David Rockefeller, if he could get a senior position there, then he could create this law. He could use UN funding to fund the fake science that produced the original models. And then they set up the global conference saying, we must protect the world, save the world, and protect the environment. So the Rio conference was organized. He got them all to sign up. And that was the trick. Because what they then did, as the governments effectively, well, they didn't sign up to making it binding. You know how the civil service works. And so did Maurice Strong and his successors. They tell the ministers what it is they should be doing. And we had signed up, America, UK, all the G7, G20 nations had said, we'll take our policy advice from you. So they no longer thought about whether it was a good thing or a bad thing. They just said, we need to build more windmills and we're missing our targets on renewables and blah, 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 which we signed up to in Rio. To which the answer should have been, well, so what? Not.
Exactly.
What? Yeah, but it wasn't. It was, we better play catch up. So they all, and then they realized there was loads of money to be made for politicians and for the lobbyists, cronies. And then all of a sudden the evidence came out to prove it was all a crock. So that got shut up really quick. So we've had 17 years of being shut up. So it's taken 17 years for people to start catching on. And if it wasn't for alternative channels and social media, there wouldn't be. It would have been a perfect storm. There wouldn't be a way of getting back.
Absolutely. Well, thank you very much. And I hope to have you back again. This has been very, very good.